In the last class, we have seen the properties of Z transform. In this class also, we are continuing with that. Now, the property is multiplication by n. Okay, so x of n Z transform is x of Z. Then what is the Z transform of n multiplied with x of n? That means signal x of n is multiplied with n. That is minus z d by dz x of z. Okay, where x of z is the original Z transform of the base signal, that is x of n. Okay, proof. X of z is equal to summation n minus infinity to plus infinite x of n z power minus n, and d by dz x of z. That means differentiate x of z with respect to z. That means differentiate on both sides with respect to z. Okay, then when you differentiate here, the first two terms, this is summation with respect to n, and this is the signal x of n. Okay, now we can do the differentiation only here because this z power minus n consists of z. So we can do the differentiation here. That is summation n minus infinite to plus infinite x of n. Okay, the differentiation of z power minus n is minus n multiplied with z power minus n minus 1. Okay, so again, we'll get z power minus n and also z power minus 1. Okay, that z power minus 1 I can take outside, and also one more minus is there here, that is minus z power minus 1 summation n minus infinite to plus infinite n into x of n into x of n multiplied with z power minus n. This we can write like is minus z inverse. Okay, and the z transform of the signal n into xn, z transform of the signal, z transform of the signal n into xn. Okay, so what we are getting, d by dz x of z is equal to d by dz x of z is equal to minus z inverse z transform of n into xn is equal to minus z inverse z transform of n into x of n. Now this z we can take here. It becomes like 1 by minus 1 by z inverse d by dz x of z is a transform of n into xn. Okay, z inverse we can write like minus z d by dz x of z, which is a transform of n multiplied with x of n. So finally, the z transform pair n into x of n is minus z d by dz x of z. So next property is convolution property. Convolution property. X of n z transform is x of z. H of n z transform is h of z. Then what is z transform of x of n convolution with h of n? That is x of z multiplied with h of z. Proof. We know that x of n convolution with h of n, just convolution formula, that is summation k minus infinity to plus infinite x of k h of n minus k. Then what is the z transform of this convolution? That is z transform of x of n convolution with h of n. Okay, that is summation n minus infinity to plus infinite x of n convolution with h of n multiplied with z power minus n. Okay, so x of n convolution with h of n is defined here. So Now instead of this x of n h of n, I will substitute this formula inside here, so that we'll get summation n minus infinite to plus infinite, summation k minus infinite to plus infinite x of k h of n minus k z power minus n is summation k minus infinite to plus infinite x of k summation n minus infinite to plus infinite h of n minus k z power minus n. So now we'll substitute n minus k, we'll substitute, let's take n minus k is equal to some new variable, that is p. Then here instead of n we'll substitute p plus k. Again the limit will go from p minus infinite to plus infinite. Okay, so summation k minus infinite to plus infinite x of k summation limit p goes from minus infinite to plus infinite h of p, because n minus k is equal to p, h of p z power, what is the value of n, that is p plus k, that is minus p plus k. Okay, so now again we'll be getting z power minus p, z power minus k, that z power minus k we'll be taking here. Okay, so summation k minus infinite to plus infinite x of k z power minus k summation p minus infinite to h of p z power minus p. Okay, if you see here, both are resembling the Z transform formula, but only the variable is different. Here they are using the variable k, here the variable is p. Okay, so it is resembling the formula of Z transform. So we can write like Z transform of signal x of k. Similarly, is a Z transform of the signal h of p. Again, these two Z transforms are independent to each other. Again, so we can replace with a new variable. Okay, again k we can replace with n. Similarly, p also we can replace with n. Okay, so finally this is x of z and h of z. Okay, okay, thank you.